Okay, so okay, great. Everything is perfect. Everything's perfect. Okay, so here, there you go. All right, so what we're gonna do is we're gonna do power series, but before power series, I want to show you a function that looks very interesting. It turns out there are multiple functions here can be represented by another functions. So let's just say, let's just take e to the x for example. So that's just gonna be e to the x, and this is kind of a overview of what's gonna happen there later. So let's just say e to the x is gonna give you a graph look like this. Wait, where's my graph? Oh, because I can do x, e to the x. Y equal to e to the x. So this is the graph. Does that make sense? Now, it's any way I can use algebraic functions to represent exact same thing. Jonathan, and you guys don't need to be completely away because we got a lot of crap we have to deal with this. So we're gonna have to put away and then we got to understand that. So y equal to e to the x. So I'm gonna show you something that's really, really interesting because it's possible for me to use algebraic representation to represent exact function of e to the x. Do you think it's possible?
Wait, yeah, say that question again.
Okay, so it's possible for me to represent using algebraic function. So this is called e to the x is called transcendental function. Transcendental function including natural log, inverse sine, inverse cosine, e to the x, natural log of x. Those are called transcendental function. Those are functions operating a little bit different than algebra function. So algebra functions like x, absolute value x, 1 over x, x squared, square root x, and all that. Those are algebra functions. Transcendental function is kind of different. So is it possible for me to use the algebra representation to represent e to the x, which is using algebra function to represent transcendental function?
I feel like it is, but it also just feels weird.
Yeah, it's really difficult. Yes, hello?
I don't want to love it.
Oh. Now it's gonna be loud class now. Connect audio. Can I mute him?
Yes, you can. Please do.
He's gonna be a talk right here. He's gonna be like,
Like at least he's in the corner when he's actually.
huh?
At least he's in the corner for you when he's actually.
I know, right? Now he's gonna be right in front of me. What's up, Connor? I only can see your forehead, Connor. Jonathan,
Yes, that is because I just woke up.
Jonathan want to see your beautiful face.
No, I don't. I do.
Bobby want to see your beautiful face.
Okay, give me a minute to put on some pants.
Great. He didn't have pants.
You didn't have pants. I think it's better.
Bobby want to see without pants. I don't want to see it, but no.
I can't see myself. This is BS.
Okay, can you put a shirt on too, please?
See,
Butt
exactly.
naked on math class? You joined the Zoom meeting butt naked, Connor.
Dude, it's a way of learning, okay?
Great. Great. Just great. Okay. Okay, so is it possible for me to represent e to the x to any type of function? So we're gonna using x and x squared and x cubed and x4. We're gonna use that to represent e to the x. So it turns out it's actually pretty cool. So we're gonna say y equal to, well, first of all, I'm gonna do 1. At least I want to have 1 point is connected, right? Yeah. You're like at 0 it's connected, great. So we're gonna add something to this function, and we're gonna look like to e to the x. So we're gonna add something like, I don't know, x. So at least middle part of that region, if you look at the small part here, right? Small part here, that they are almost identical. They're almost identical. Without issues, they're almost identical. So then you say, is it possible if you keep on adding certain type of equation? It actually did. So we're gonna add another equation. We're gonna call it x squared and over a 2 factorial. I don't know what the hell is factorial. It's right here. So now you see that the part of overlapping start getting more and more.
Yeah.
And can you guess what the next function is going to be? x cubed 3 factorial. Good. Good job.
Really? What did she?
3 factorial. And if you see that this overlapping start getting more and more, so that's just going to be plus x to the 4th divided by 4 factorial. So you can probably get a point, but eventually it's going to look almost identical if I go further enough. Now it's already like between -1 to 1. It's almost identical. You can barely see the difference. Word turning, yes. That's what. Because,
what is the point of this?
how do I get rid of this?
I don't know.
Well, what's going on?
I don't even know you put on the screen. Are you a carpenter in your free time?
Yeah.
Can you take this carpeting?
No.
Like, you know, on the
Like after the AP exam, can you just see this other hardwood?
Oh, by the way, for some people that is wondering, like you cannot feel like you can accomplish something. Like that was like my biggest afraid. Like when I'm like doing something, right? And like, so for example, I'm doing a problem that I didn't know how to do. And my biggest fear for you guys too, for myself as well, is like I cannot accomplish your problem. Have you had that fear before? You don't know like if you can accomplish it, right? You don't know if you can score that goal. You don't know if you can make that shot. So that's always like a doubting of yourself. And so I always like convince kids like, you don't need to doubt yourself. You can suck at something, but you still can finish the product. And so I don't know what the pictures is. Hold on a second. Anyway, I can see the picture, but anyway, it was I'll show you guys next time. But anyway, so the idea is the e to the x, if you keep on going to the 5th power divided by 5 factorials, and you're gonna see that divided by 5 factorial. And if it goes to infinite, you will get the graph almost look exactly the same. So that the left part of the graph will start bending more and more and more and more and more. And as you adding more function to it. Okay, so as you're adding more function to it. So this is the e to the x. So we're going to talk about something called power series. As opposed to yesterday, opposed before, that we have some type of series, but we never have x involved. X gonna be coming involvement here in terms of understanding. So now we're gonna build this. The idea is try to build a function that look like this through power series. But before that, we have to understand what is power series, what's radius of convergence is, and what is those things is. So let's give you couple definitions.
What's the second thing that you said after power series?
Radius of convergence. Yeah, radius of convergence. So now we're gonna say, hey, this is just a book definition. So this definition of power series. So that we're gonna introduce you this one. So this might be something that you need to know. So definition of power series. So this is obviously very important. So
Mr. Ye,
yes.
did I miss anything before this, or just like the first topics that we've done?
This is the first topic that we've done.
And by the way, I'll be there tomorrow for the long block schedule.
Yeah, but we're not gonna go through this lesson again because yeah.
No,
But
I
anyway.
know. I'm just saying separately. Like I'll like, you know.
All right. So n equal to 0 and infinity. A(n) to the x to the n power. Do you see that I can represent the function that we just did using x to the n power, because n is the first term is n is gonna be, so for example, if I have the first term is gonna be a to the 0. But anything to the 0 power is 1, so therefore just a to the 0. Does that make sense? Which is in that last case was a 1. Right? So This second case, this you're gonna keep on adding. This is a1 x to the 1 plus a2 x to the 2 plus a3 to the x3. So technically, I can represent e to the x using the power series. So I can represent that. But I suppose before we just only summation of a to the n or something like that, some type of sequence. Now we have x is involved. So we say here, we're going to write down here, if x is a variable, if x is a variable, then infinite series of the form is looking like this. It's called power series, which is a very big deal. Now, sometimes they can have a different center. At this case, the case that we did is center at x equal to 0. We did not do any shift. We start at 0. We start to find out a little bit of everything. So we start at 0 and we go into try to come up with the graph that's very similar to that from the 0 and move on both ways. Does that make sense? And so what we did, we move on from 0 to both ways. Can they center at off 0? Yes, they can. So there is actually power series center at C. So more generally, it's going to be represented this way. More generally, it's going to be represented this way. So at an infinite series of the form this n equal to 0, infinite, and a to the n to the x minus c to the n. And with that, the only thing different is you're going to realize that the only thing different is going to be a to the 0 plus a to the 1 times x minus c to the 1 plus a to the 2 x minus c to the 2. And just dot, 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 dot. Now, at here, it's going to be some type of, sorry, let me say dot, 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 a to the n, x to the n. And this one is going to be a to the n, x minus c to the n. So that's pretty much it. So that's power series. So first of all, to introduce that, we said e to the x can be represented as a power series, which is 1 plus, we got x over 1 factorial, right? So plus x squared over 2 factorial plus x3 over 3 factorial plus x4 to the 4 factorial. It turns out later on, we also learn what is sine of x and what is cosine of x. Okay, it turns out later on we're going to learn what is the power series for sine of x and cosine of x, and then we can use that to do different type of problem. Okay, is anything that I'm confusing you here? No? Okay, so we're going to go to the next page. The next page says, well, first of all, let's learn how to write down power series. So for example, how would I write this e to the x? How would I write that e to the x here? How do I write this ex in terms of some type of power series? Don't say it, Luke. I know you got it. But I want you to think about it. N equal to 0, infinity. I'm going to do the easy part for you. So how do I represent that e to the x using this? Okay, so I want you guys to think about it. Wow, counting could be annoying on the chat too.
I didn't even say anything.
I know.
Yeah, you just.
Yeah, I can see it from the. Wait, who can see from the chat? Wait, that's on my live stream. Who's that?
What?
Somebody writing stuff. I don't know who that is, but how do I ban them?
What you have to do is you punch the computer,
Oh well.
and then it should do it.
I can bend them, but oh, whatever. So how do I represent e to the x? Any ideas?
Wouldn't it just be x to the n over n factorial?
X to the n over n factorial. That's perfect.
You made it seem like it was going to be way more difficult. Yeah.
No, it's not. It's not. We just go through here, and that's a power representation of that. Is there any questions here?
Is that just something you have to like memorize and you've done this before?
No, you actually get from here. Look at this 1 factorial, 2 factorial, 3 factorial, 4 factorial, right?
Yeah, but like.
Well, where the factorial? Like from the formula.
Yeah, how do we know to use factorial in these problems? Like, it kind of feels like that just came out of nowhere.
Yeah, so later on we're gonna learn how the Taylor series work, and how the McLean series work. But we have to start by understand what this radius convergence is and how to do other things. So we have to understand that first before we go on further. So now, what is radial interval convergence? We're gonna talk about that. So what's the radius of radius and interval convergence? And this is a very popular questions.
Integral, right? Or interval?
Interval.
Interval.
Convergence. So remember, x can be some type of value. If x is some type of value that is not in the radius of convergence, that means this thing will go divergent. If it's divergent, I cannot use that series to represent the function. So it must be some type of value in terms of x, and that x can be represented for the whole series to work. That is convergent. So that's why we got to find. We want to find out the interval of convergence is. On x is what value to what value is this series convergent? And we did some type of question like this before on the last homework that we did, but you got to think about all those things and things like that. So for that nature here, we had to think about, okay, so what kind of situation it can happen. That just say, if I have a convergent of power series, so there was 3 type of series can be true. So the first time there was 3 situations. The first situation and the second situation and third situation, there are 3 different kind of situations. It says for a power series center at C, precisely one had to be true. Precisely one of the following must be true. One of the following must be true.
One and only one?
Following must be true.
One?
Yeah.
At a time?
Yeah, one.
One at a time? Like it can't be multiple ones?
Precisely exactly one. Only one. It's first situation or second situation or third situation. The first situation is kind of boring. Is the series converge only at C.
Right.
The series converge only at C. Now, what do you think this radius is if it's only converging at one point? Zero. Who said zero? Good job. It's 0. Because you think about if we have one dot on the number line, like say 2, right? Only convergent at 2. There's no radius to that. It's only one dot. So radius is exactly 0. So that can only happen in that situation over there and that particular C. And like I said, that is a boring case. The second one is also boring. Is the series absolute convergent for all x. Doesn't matter what you plug in. So the series always converge. The series converge absolutely. Sorry, that was really bad. Absolutely at all x. So that's boring. The case that you're going to be encounter the most is the third case. Okay, the third case, it says there exists an interval of a real number r is greater than 0. So radius of convergence is greater than 0. So that means it must be at intervals. Interval of what? From maybe 1 to 5. I think in algebra 1, you get some type of situation. You say build a function where is represent the interval 1 to 5. So you had to pick the center. What is 1 to 5? The center is going to be 3, right? So then it's going to be 3, and then maybe x minus 3 is less than 2. So that will says is x could be 5 or x could be 1, any range of values there. So we can talk about that a little bit more. Let's go back, review some algebra 1. So
Does R stand for radius or real number?
R stands for radius in this case, radius of our convergence. Okay, so give me a second. We'll talk about that. So that's why we're gonna spend this long period to talk about this, because there's probably a lot of confusion, and also the fact is this is the first time I teach this, so it's gonna take a little bit longer. But I'm trying to go very slow so where you can understand. Series converge absolutely for x minus c is less than r. And diverge, which is what we don't care about, diverge at x minus c is greater than r. Now let's talk about a little bit of that. Let's talk about a little bit of that.
Oh, okay, I think I get it now.
Okay, so let's talk about a little bit of that. So let's just say if I want to represent this function, let's say the convergence of radius is between 1 to 5, right? So the number anything between 1 to 5, if I insert here, the series is always going to converge. That's called radius of convergence. But in this case, what is my radius? This is an example. Radius is 2. And where's my center? 3, right? So you can rewrite as this: x minus 3 is less than 2. So you can represent this like this. Is, you know, this is not coordinate. This is 1 to 5. This is interval notations. Interval notation.
Why the radius is 2?
What?
Why the radius is 2?
I don't understand your question.
Why the radius is 2?
How do we figure out that the radius is 2?
Because if you start at 3, right? So let's just say between 1 to 5, what is center at?
3.
3. So 3 go to 5 is what?
Okay, yeah.
3 minus 2 is what? 1. So that's how you're going to get there. So if you want to solve this algebraic function, you're going to get x minus 3 less than 2. X minus 3 is greater than negative 2. And that is going to be x is less than 5. And this is x greater than 1, I think. So that's going to be radius convergence is going to be from here. It's going to from, this is a 0, 1 to 5. So this is a 3. So 3 go to here, 3 go to here. This is my interval. So those are the things that sometimes if a radius convergence between 1 to 5, this is a purely good representation. Why? Because this is going to be your center, and this is going to be your radius. And sometimes we will ask for that. The number run part. Okay, so let's just say if I have radius convergence between 1 to 5. So that means any number I plug in between 1 to 5, it's okay for the series to converge. So that happens. If that happens, I can represent using this. Now, why is this? Because you start at 3, that's my center. And if you have, so you pick the 2 endpoints, and you pick the middle of 2 endpoints. So that middle endpoint is going to call the center. But center plus the radius and center minus the radius is going to give you the interval. Does that make sense? So that basically is called interval convergence. So we can go through a couple cases where that you guys gonna see something and you're gonna see, oh, okay, is this true or not? Now let's talk about other cases.
Can you like show like a graph, like what the radius is on a graph?
Okay, so
I don't really
so let me show you the first point. The first point is gonna be like this. It's just a value C. This is the only point that's violet. Okay. So hold on a second. Let me do that on the first part. This part, yeah, this part is the right one. So let me just do it the right one. So this is gonna be the first case. Is C. This is the only time there's convergence at this value. And the series of convergence all series, that's pretty much the whole number line. C, but it's a whole number line. The whole number line is gonna be also converge. Now, where is 3? Give me a second. So if it's a 3, then you're gonna have a C, and the C is some type of value, is between 2 intervals, is right in the middle of 2 intervals. So here it's gonna be pretty much this is C minus R, and this is C plus R. And so those are the interval of convergence right here. And this can be represented using this. X minus C less than R.
isn't like you're given like a function.
Or sometimes we have to find it. We have to find where is the radius convergent. Usually we don't ask you the other way around, ask you what the equation represent 1 and 5. But I'm just showing you right here to help you guide there. Because later on we just only have to find 1 and 5. And sometimes we have to do bracket 1 and parenthesis 5 just because the endpoint also apply differently. Yes, Connor.
So what are we, when we have a problem like this, what are we trying to actually find?
We're trying to find the good question, because so some type of interval here, right? Just for example, this one. If this one occur, now can I plug in some type of x value? It's gonna make it convergent, because so it must be a domain for this x, and this x is going to be from what value to what value, whether it's a single value or infinite amount of value, or a radius of convergence between 2 values. Between those 2 values, this series actually converge. Okay, because if it's diverge, this will not be true. This will not be true. Only work if this is convergent. So the x has to be in some type of value that represents that. And you're gonna be like, okay, well, I cannot think abstractly. Give me an example. Let's say that we can go. So that's what we're gonna do. We're gonna give you some type of example. Then you can say, okay, well, what does this mean? So we're gonna give you some type of example. And usually, the question is gonna start with the format of type of this question. You're gonna start with doing ratio tests. And why ratio test, not any other test? Well, the ratio test is nice because ratio test tell you something. So what does it tell you? Let's review again. Absolute value an plus 1 over a to the n is less than 1. Sorry, less than 1 is converge, right? If a to the n plus 1 over a to the n is greater than 1 is diverge. and then a to the n plus 1 over a to the n is equal to 1 is inconclusive. So inconclusive. Wait, this is not this is a whole period? 2 hours?
No, we have a block here tomorrow.
Oh, we have block period tomorrow. Okay, good. Okay, so that's good. We finished this part. It's perfect.
Bye, Mr. Day.
Bye, good day.